Hi, sixth grade. This is a short intro video to the changes of state of matter. So you learned about the basic states of matter, solid, liquid, and gas. And I just want to kind of draw your attention to some concepts that we're going to have to go back to and really kind of focus on in order to make sense of changes of state. And those two really important concepts are going to be density and thermal energy and kinetic energy. So what we see here, this is a simulation, and this is, if we look over here, they're atoms of neon, and right now they're in the solid state. And so what you can see is that they are moving, so they do have some kinetic energy, but not very much. And as we add thermal energy to it, we can see that they start to move faster, which means that they are increasing in kinetic energy. And we see that they're actually going to start to change state. And right now, majority of it is a liquid with a few particles that have changed into a gas. So if we look over here and click on liquid, we can see how they're kind of just moving around a little bit more. They have more kinetic energy. And then a gas, they're moving around really fast, they're really spread out, so they have a lot of kinetic energy. And how we can change this from solid, liquid to gas is adding kinetic energy. So if you watch the thermometer, that's how we measure kinetic energy. As the thermometer rises, we know that we have more and more kinetic energy, and we're adding more thermal energy. So you can see we're starting to melt and change into a liquid, and now we're turning into a gas. And you can see the thermometer rising over there. Now, one thing that we really kind of want to focus on, we really just briefly touched on the whole energy concept. I want to talk to you about density. I want you to be thinking about, what state of matter is the most dense? What state of matter is the least dense? And so if we look at a solid, a liquid, and a gas, think about where the particles are compressed the most and they're packed tightly together, and where they're able to spread out. You should be saying that a solid is going to be the most dense, that a liquid is a little bit less dense, and the gas is going to be the least dense. And if we look even at like oxygen, we're going to see that it's the same for no matter what. Now, when we get to water, you're going to notice that water looks a little bit different. Water is a very, very weird substance. It's actually really cool. We kind of take it for granted because it's everywhere. But water, when it's a solid, is actually a crystalline solid. So ice is a crystalline solid. And you can actually see these little patterns right here that they're forming. And so actually, when they're in a solid, it's less dense than when our particles are in a liquid. We have a few particles up there that are gas. But I just wanted you to kind of be aware that when you are looking at a whole bunch of different pictures, if you see particles that look like this, and you can kind of see 3, 4, 5, 6, a hexagonal pattern to it, that's meaning that you're looking at ice. Water is one of the very few substances that actually do this. It's very, very weird. All of our other substances and solids are very closely packed together. Water is where we're seeing that crystalline, that pattern kind of like that. And then when it goes to a liquid, it looks just like any other element, or all the other elements that we are looking at: oxygen, argon, and neon. Now water is a compound, but it still looks very similar. The molecules are just close together. And then for a gas, again, it looks very similar to the other substances that we have in here. So there's water, there's oxygen as a gas, argon as a gas, and neon as a gas. So I just wanted to give you this brief introduction so that you are aware that the whole time we're thinking of changes of state, always be thinking about what's happening to our energy level, and then also what's going on with the density of the different phases.